The construction of the new Everton Stadium at Bramley-Moore Dock in Liverpool represents one of the most audacious maritime civil engineering projects in modern sports history. With a total cumulative investment approaching £800 million, Everton Football Club transformed a semi-derelict Victorian dockland site into a state-of-the-art 52,769-seat maritime stadium. Let's analyze how marine engineers successfully infilled a historic working dock with sand harvested directly from the Irish Sea, preserved Grade II listed heritage structures, and balanced traditional Liverpool brickwork architecture with cutting-edge stadium design. If you enjoy technical breakdowns of global sports infrastructure, stadium finance, and urban waterfront regeneration, make sure to subscribe to the channel and turn on notifications. To understand the geographical and historical significance of this project, we must examine the club's transition away from Goodison Park. Opening in 1892 in the dense Walton area of Liverpool, Goodison Park was revered as one of the world's first purpose-built football grounds. However, closely bounded on all four sides by tight residential terraced housing streets, Goodison Park faced insurmountable spatial and physical limitations. The multi-tiered wooden and steel stands suffered from restricted sightlines, decaying timber infrastructure, and virtually non-existent corporate hospitality revenue compared to modern Premier League venues. Moving to Bramley-Moore Dock on the northern banks of the River Mersey allowed the club to secure a dramatic waterfront anchor location within Liverpool's historic maritime industrial corridor. However, building a major sports venue directly on top of an active 19th-century dock basin required solving extreme marine civil engineering and structural preservation challenges. When we examine the technical scheme, the engineering required to prepare the site was extraordinary. Before structural foundations could be laid, marine contractors had to execute a complete infill of Bramley-Moore Dock. Dredging vessels pumped over 480,000 cubic meters of fluid sand harvested from the seabed of the Irish Sea directly into the water-filled dock basin. The water was gradually displaced and filtered back into the Mersey estuary, leaving a densely compacted subterranean sand foundation. Over 2,500 heavy concrete piles were then driven deep into the underlying sandstone bedrock to support the structural weight of the steel venue. Architecturally, the stadium, designed by Mice Architects and BDP Pattern, pays homage to Liverpool's industrial maritime heritage. The lower base features dynamic openwork red brickwork, mirroring nearby historic dock warehouses, while the upper structure transitions into a light metallic and glass canopy, reflecting the Mersey skyline. Inside the bow, the focal point is the massive single-tier south stand, known as the home end. Designed with a steep 34-degree incline, this 13,000-seat wall of sound places supporters extraordinarily close to the pitch, maximizing acoustic reverberation and home field advantage. Additionally, the historic Grade II listed hydraulic engine house on site was meticulously restored and integrated into the fan plaza as a year-round heritage asset. From a financial perspective, the capital stack and economic impact present a compelling story of private urban investment. The total project cost escalated to approximately £800 million due to global supply chain inflation, material costs, and complex marine engineering requirements. The project was funded through private equity injections and long-term debt refinancing arranged under new club ownership via private credit facilities. Despite the financial strain during construction, economic impact studies project the stadium will generate a £1.3 billion boost to the local UK economy, create over 15,000 jobs, and attract millions of annual visitors to northern Liverpool. Furthermore, securing official host venue status for UEFA Euro 2028 unlocks long-term international broadcast visibility and accelerates municipal transport investments, including upgraded Merseyrail station connections. In conclusion, the new Everton Stadium at Bramley-Moore Dock stands as a triumph of maritime civil engineering and waterfront regeneration. By transforming a dormant Victorian dock into a modern football cathedral, the project bridges Liverpool's rich industrial past with its sporting future. The strategic combination of historic brick architecture, extreme marine infill engineering, and an intimidating steep homestand proves that modern stadium design can enhance regional heritage while maximizing commercial performance. How do you view the trend of relocating historic football clubs to waterfront regeneration districts? Share your opinion in the comments below and subscribe for our next deep dive investigation into global sports infrastructure.